Hello. In our previous video, we talked about the exponential growth model. But today what we're going to do is we're going to talk about something that's called exponential decay functions. All right. So exponential growth, if you remember, is as my x values are increasing by 1, my y values are being multiplied by a certain value, and that certain value happens to be an integer, and this integer here, if I take 1/27th and multiply it by something to get 1/9, that has to be multiplied by 3. And multiply this by 3, multiply this by 3 to get that, and then multiply this by 3. So that's exponential growth. Is as my x values are increasing, my y values I would have to multiply by 3 to get the next one. Whereas if I had exponential decay, notice that once again my y values are increasing by 1. Okay, but now if I look here, I am multiplying by something, but what would I have to multiply to go from 16 to 4? Here I'd have to multiply by 1/4. Notice that I'm multiplying by a fraction for exponential decay. So here, to go from 4 to 1, I would be multiplying by 1/4. Here to here, multiplying by 1/4. And here to here, I'd be multiplying by 1/4. This right here is showing me that my function is going to end up being exponential decay. Whereas if this here were an integer, it's going to end up being, or actually a whole number, it's going to be exponential growth. All right? So, what rule represents this function here? If we remember that my rules generally follow the y equals a times b to the x, okay? I just need to figure out what a is and what b is. Remember, a is always where x equals 0, so I know this one is initially going to be y equals 1 times something. But now if I look at this, if I go from here to here, yes, I'm increasing by 1. Going from here to here, yes, I'm increasing by 1. Going from here to here, yes, I'm increasing by 1. But if I go from here to here, I can see that I'm multiplying by 1/5. Going from here to here, multiplying by 1/5. Going from here to here, I'm multiplying by 1/5. So now my value for b is actually going to be 1/5. Notice that because this is a fraction, I need to isolate that fraction because the whole fraction is being taken to that exponent of x. Okay? Some people will write it like this. And when you write it like this, only the 1 is being taken to the power of x. So write your numbers correctly. So this would end up being y equals, because 1 times anything is itself, 1/5 x. 1/5 to the power of x, excuse me. Awesome. So that's how we come up with our rule. We're using the exact same one, but now we can see that our factor here is going to be 1/5 rather than the whole number. So graphing an exponential decay function is going to look a little bit different than when we graph the exponential growth function. So once again, I can assume any values for x, and I'm then going to make a table by substituting the values in here and then solving for y. Once again, I'm going to first start with 0 because that's always the easiest one, because 1/2 to the 0 power, anything to the 0 power is 1. So I know it's going to have this value here as x equals 0, y equals 1. If I substitute 1 in for x, anything to the 1 power is just itself. So I know this is 1/2. And then this is going to be 1/4, because 1/2 times 1/2 is 1/4. And then let's go and do these now. So if I have 1/2 to the -1 power, that's the same thing as saying 2 to the 1 power. So this is going to end up being 2. If I have 1/2 to the -2 power, that's the same thing as saying 2 to the 2 power, which is 4. That's why we have to learn how to work with exponents, so that now we can work with exponential functions. So now that I have this, I can see when x is -2, y is going to be 4, so it's going to be that point right there. When x equals -1, y equals 2, it's this point here, 0, 1. When x equals 1, y is 1/2, and then 1/4 is going to be like right about here. Notice that Now my function looks something like this. Woo! And then like this. And will this ever cross the x-axis? If you think about it, as my x values increase, okay, is the y value ever going to be negative? No, it's just going to be a smaller fraction. So, once again, will never cross the x-axis. And because of that, now I can figure out what my domain is. My domain is what my x values can be. Once again, my x values can be anything, so it's all real numbers. But then my range is going to be the set of all y such that y is greater than, can't equal 0, it'll never equal 0, 0. And there you go. We plotted our points, we drew a smooth curve through the points, and we came up with our domain and range. That, ladies and gentlemen, is what an exponential decay function looks like. Bye!